trying to access this particular object S inside a function which is belonging to completely different class. So this is how I can pass this particular object to any function which belong to any other class. So this is one of the very important use cases of. Hi all, this is me Karan. So in this particular lecture, we'll try to understand the different properties and uses of this keyword in C++. We have already understood the basic idea behind this, what is the meaning of this, and how it is passed to any function. So let's try to understand its uses and properties. So let's start with the first property. This works as a pointer to the object. So what is the meaning of this? Let's say I am creating the object of this strategy class S, and this strategy class can contain different member variables and member functions. So what will happen? I am creating the object of this particular class S, and let's say that object is getting created at memory location, let's say 100. So now because I am creating the object of this strategy class S, so I will be calling the constructor of strategy which will provide the default value to this particular member variable. So in this case, order quantity will be 0 because I am not explicitly providing the constructor to set the value of this particular member variable. And for the first property, this will work as a pointer to the object. So if I am accessing this inside the strategy class, it means it will work as a pointer to the strategy class object S. So basically inside any of the function of strategy class, if I am saying this, it means I am pointing to the strategy class object S. So this is the meaning of first pointer. Now if I talk about the second property, then I can say this is available in all the non-static member functions. So inside any class, there can be two types of functions. First one is static function and second one is non-static functions. So if we are calling any non-static function, so in this case, this is a non-static function. And if I am calling this particular function as dot set quantity, then I can access this inside this particular function. Why? Because this is a non-static function. But at the same time, if I try to make this as a static function, and now if I try to call this particular function using object S, then I cannot access this inside this particular set quantity function. Why? Because now this is a static member function. So I cannot access this keyword inside the static member functions. Why? Because static member functions are not associated with the instance of the class. So what is the meaning of that? So let's say I am creating the object of this class S. So this particular static member function will not be the part of this object S. So you will understand why we cannot access this inside a static member function when we will talk about the static keyword in C++. So if I talk about the next point, then the point is this is a constant pointer. So basically what is the meaning of this? So let's say I am calling the set quantity function using this object S, and inside this set quantity function, if I try to do like this equal to address of some other object apart from S. So this is not allowed. So as of now, what is happening is this is pointing to this particular object S, and here I am saying that please don't point to this particular object. Instead of that, point to some other object. So this is not allowed. So I cannot assign some other object's address to this. So basically this is a constant pointer. It cannot point to some other object. It will only point to an object which is calling this particular set quantity function. So in this case, S is calling this set quantity function, and this can only point to this particular object. Now if we talk about the fourth point, then I can say it is used to differentiate between member variable and parameter with the same name. So what is happening? So what is the meaning of this? So let's try to understand that. So what is happening here is I am calling this set quantity function s dot set quantity, and here I am providing the value to order quantity as, let's say, 100. So this is my member variable order quantity, and I am capturing this particular value 100 in this order quantity variable. And if I simply do this, order quantity equal to order quantity, so compiler will get confused whether this particular variable is the member variable or this local variable. So to differentiate them, I will do like this and order quantity. It means that I am trying to access the member variable order quantity which is associated with this particular instance of the class. So in this case I am trying to access this, and this is my local variable. So now if I want to modify the value of this particular order quantity variable, then I can do this order quantity and some other new value. But if I am simply doing order quantity and not using this particular keyword, then it will update the local variable instead of the instance variable or member variable. So this is used to differentiate between the local variable and the instance variable or member variable. So whenever you are saying this dot variable name, it means you are trying to access the member variables associated with this particular object. And when we are simply using any variable using that variable name, it means that we are trying to access the local variable. So if I talk about the next point, then I can say it is used to return the object itself. So sometime it does happen that we need to return the object of this same class from some function. So let's try to understand that. So let's say I want to return the object of strategy from this function. So what I will do, I will just do some operation on this object. Let's say this time I am trying to modify the value of this member variable, and I am making it as let's say 100, and I want to return the instance of this particular object which is calling this particular function fun. So what I will do, I will simply return pointer and this, and I can capture this here from wherever I am calling this particular function fun. And at the same time it might happen that I want to call the function which is belonging to some other class, and there I want to access this particular object as, then what I can do, let's say there is class X and it contains some function 1, and inside this function I want to access the object of this particular class S. Then what I can do, I can call X and fun 1 and pointer this. So this way what I am doing, I am trying to access this particular object as inside a function which is belonging to completely different class. So this is how I can pass this particular object to any function which belong to any other class. So this is one of the very important use cases of this. And when you will see production level code, at that time you will find tons of this kind of like function calls. So this is very important from that perspective. So I hope all these properties and uses of this are clear to you. In the next lecture, we'll try to do experiment around all these things, that how we can do this, how we can find out the address of this, so those kind of things. So till now, if you are confused about this, just go through this particular lecture again, and at the same time try to focus on the assignment which I'll give you after 3 or 4 lectures, which will be based on this keyword. So if you follow that, that will be really helpful for you to understand this keyword in C++. Thank you.